In December 2025, OpenAI declared an internal code red. Google's Gemini 3 had just surpassed GPT 5.1 on key coding evaluations like SWEBench. That rapid leapfrogging proved a crucial point. No single AI giant holds a permanent technological moat. The lead shifts constantly. With models now generating code faster than humans ever will, the primary challenge has moved. The bottleneck is no longer the intelligence itself, it's the orchestration and architecture required to make that intelligence useful. Developers are facing serious friction. You must choose between high costs on proprietary APIs, significant time configuring open weights, or tools that lose context. This chart maps the 2026 stack by comparing your resource footprint on the horizontal axis against your need for agentic autonomy on the vertical axis. We evaluate this landscape through three specific lenses: the enterprise architect, the startup developer, and the edge builder. Each builder profile sits in a different spot. Enterprise needs high autonomy with massive cloud resources. Startups need high autonomy but have tighter resource constraints. And edge builders require tight, local footprints. Success in 2026 depends on abandoning a one-model-fits-all mindset and matching your specific constraints to a modular architecture. We start at the top end of the compute scale, the proprietary titans. Models like Claude 4.5, Gemini 3, and GPT 5.2 are heavyweights designed for complex coding and knowledge work. This comparison table shows performance on the Suibench evaluation. Anthropic's Claude Opus 4.5 leads with an 80.9% score, securing high enterprise trust. But Claude is constrained by a 200,000 token limit, often requiring developers to manually chunk data for massive refactors. That brings us to Google's Gemini 3, which offers a distinct counter-advantage for large-scale data ingestion. While Gemini 3 lags slightly behind OpenAI in pure mathematical reasoning, it features a massive 2 million token context window. You can ingest an entire codebase into a single prompt, avoiding the complexity of data chunking entirely. Then there is OpenAI's GPT 5.2. Its specific strength is reliability, achieving a 98.7% success rate in tool calling and API interaction. The trade-off is that relying entirely on GPT 5.2 forces infrastructure lock-in. As your product scales, you move directly into incredibly high API costs. These proprietary models offer peak reasoning performance, but you are tying your product's fate to a vendor's expensive API ecosystem. To escape those API costs and guarantee complete data control, we look at the opposite end of the spectrum: open-weight models running locally. For zero-latency on-device mobile applications, Google's Gemma 4 family provides the E2B and E4B models. Running these models directly on the device ensures data privacy and the ability to process native audio and video entirely offline. The trade-off is capability. To fit a model on a phone, you sacrifice the deep logical reasoning found in a 30 billion parameter model. There is an intermediate solution for consumer hardware: the Gemma 4 26B Mixture of Experts model. A Mixture of Experts architecture achieves faster token generation by only activating 3.8 billion parameters at any one time, rather than the entire network. However, you still need enough physical VRAM to load all 26 billion parameters into memory simultaneously to maintain those speeds. Open weights offer data sovereignty and direct cost control, but they shift the entire burden of infrastructure and memory management onto the developer's shoulders. We've looked at the foundational models, but these systems don't build software in isolation. The bridge between raw model output and a functional application is the orchestration layer. A critical piece of this infrastructure is the Model Context Protocol, or MCP. It is an open standard that gives AI structured access to external data. With MCP, agents can query JIRA, read through Figma files, or pull from private databases. When context is structured, the model makes far fewer assumptions. The trade-off is that MCP requires significant upfront engineering time to build and configure the necessary connectors. This flowchart illustrates adversarial agents, elevating code quality beyond basic autocomplete. One agent writes code, a second tests for security flaws, and a third adjudicates the synthesis. But this adversarial loop doubles your API costs and increases pipeline execution time. To make this work, you need strict system prompt structuring. assigning highly specific skills to subagents to generate reliable, complex outputs like a formatted podcast script. The competitive advantage in 2026 comes from building tight, purposeful integration loops, not from blindly pinging the smartest foundational model. This decision tree maps our evaluations directly back to the 3 builder constraints we discussed at the beginning. We will start with the enterprise architect. Your budget is high, but the need for security is absolute. You should standardize your core engineering tasks on Claude Opus 4.5. Absorb the higher API costs and implement adversarial agent loops in your CICD pipeline. Catch security flaws before they ever reach production. If you are a startup or an indie hacker, your constraints are different. You need to prioritize leverage. Utilize Gemini 3's massive context window to gain full code-based understanding without building custom chunking logic. Adopt CLI agentic tools and wire everything together with the model context protocol, granting the AI full visibility over your business data. Finally, we look at the edge and hardware developer. You must prioritize footprint. Avoid API reliance entirely and embed Gemma 4's E2B or E4B models directly on the device. This local architecture guarantees zero latency execution and total data privacy. Winning developers in 2026 do not force workflows to conform to how AI works. They build modular stacks that fit exactly into how developers already think and build.